In 2008, the Nelson Marlborough Institute of Technology ran a competition to design their new arts and media building. A Nelson architecture company won it. The project incorporated laminated veneer lumber, or LVL. In 2012, the innovative design was built using local people, processes and product from Nelson forests. The story of this building begins in the forest at harvest time.
Nelson Forest has a 78,000 hectare estate in the top of the South Island, based in the Nelson and Marlborough regions. We harvest 1 million cubic metres, which is just over 2,000 hectares, and every year we replant that area as well. So it's a sustainable basis, and we supply 70% of our product to domestic customers. So Nelson Pine, Carter Holt Harvey, Waimea, and all the logs that the domestic customers aren't able to process or aren't suitable for their processing, we export those into China and Korea. In the top of the South Island here, it's a high density region for radiata pine, and it's largely a result of the way the radiata grows here. It's a very good growing area, high sunshine hours and good temperatures. So it grows for a long period during the year. And also the area is characterised by trees with very small branches, which is obviously also good for structural applications like LVL. On the hill we've got a felling machine that harvests trees automatically without anybody on the ground. Once that tree is put on the ground, we have another machine that comes and bunches the trees together, and then another machine comes along, which is a skidder with a grapple, picks up the bunches of trees, drags them to the landing site, and then we have a Waratah processing machine that takes those logs, delimbs them and cuts them into log lengths. We program the computer to generate the highest value. Different log grades have different values, and as he's processing the log, he's looking to extract the highest value out of that stem. And then once that process is finished, a loader will take the logs away, put them into storage stacks until a logging truck turns up, and then the logging trucks will be loaded with the loads of logs. This is a stack of log that will be taken to Nelson Pine and manufactured into laminated veneer lumber. Typical characteristics are nice and cylindrical, very straight, small knots and very tight growth rings. It's telling us that it's very good quality and high density and high stiffness, which is a prerequisite for laminated veneer lumber. In terms of LVL, it's been fantastic for us. It's added value to our business. It's also added value to Nelson Pine and to the building industry as a whole.
We process 1 million cubic metres of logs per annum, which is close to 40% of the total harvest from the forest in this area. And we manufacture from that 350,000 cubic metres of MDF, and we also produce 80,000 cubic metres of LVL. The main market for the product that we produce is now for making scaffold planks and formwork for the Middle East is one of the main markets. What makes it really attractive and what its strong point is that we take the veneer from a log and we reconstitute that by putting the strong veneers on the outside and the weaker veneers in the inside of the product, and we make a product that's got very high strength and dimensional stability. The vision is to focus on the structural properties of the product we make and have it used in buildings in structural applications. I think the real opportunity for LVL is going to be in Christchurch after the earthquake, where there's a lot of talk about building wooden buildings, and that's something that we're really focusing on at the moment. When you look at the value add we get out of LVL, particularly when you fabricate the products into the components that went into the building at the NMIT, the value add is around about 30 times the value of a log. One of the things that Hunter Laminates do is they take our product and they fabricate it into components for buildings like shear walls, beams and columns. Also, they do a Proteus flooring system as well using LVL. And those products were transported directly from Hunter Laminates to the NMIT building and assembled on site.
Laminated veneer lumber, LVL, is the process of peeling a log and then taking the veneers from that and putting it back together into a board or a sheet. Now this can be done at 1250 millimetres wide, up to 18.4 metres long, which is longer than the logs that it's starting with. Part of it is then about getting the grain and all the structure of the timber orientated in the same way. And effectively, we're making the equivalent of a steel product in timber. When you peel a log, you're taking off a thin section of that log, I think 3.73 millimetres thick, and it actually looks like a piece of paper, really, to start with. When we relaminate that back together and to make the LVL, what you end up with is a very stiff and very strong piece of timber. In fact, stronger than the tree that it started from. The sheets are glued together using a resorptional adhesive. That's put through the plant under a high pressure and high temperature process, so it's a continuous process, so all the time the plant is running, there's the sheets are being put in and they're being taken out at the end of the line continuously. From an engineering point of view, it actually makes it a lot easier to design with, because you've got a set of characteristics for the product that you know it will do every time. Sometimes when you're working with normal timber or roundwood, then you've got a situation that you're not quite 100% sure exactly what it's doing. When you're working with LVL or an engineered wood product, the engineered bit says it, you know, it's actually got set characteristics, you know what it's doing, you've got a set of tables there and you can say, right, this will do this and it will do that.
Andrew Irving and his team from Irving Smith Jack Architects came up with the winning structure for NMIT's building in Nelson.
The brief was in two parts. One was to satisfy NMIT's sort of requirements for an arts and media building. The second half of this project was about an aspiration from the Ministry of Agriculture and Forestry. They were looking to institute a series of landmark timber structures, and so they sponsored NMIT to run an architectural competition for a landmark timber building and provided a degree of top-up funding to pay for the innovation that might entail. We wanted to make a building that was local. We thought that being a local architect, using local product and local contractors would be an appealing thing for NMIT as part of a reasonably small community. So one of the things that drove our design philosophy was to make as much of this as realisable and as repeatable as we could. But we knew that we were going to have a trick to beat off the rest of the architects as well. And so our trick was to think about making our seismic resisting systems, one, out of timber, and two, using a kind of technology that no one had used before. So that's this notion of damage avoidance design, which is kind of a jump on in terms of a seismic protection system. We didn't think we had any options other than to use LVL because it was the only timber product we could get the kind of spans that we were looking for from. And so at really early days we were starting to talk to the guys at Nelson Pine and a couple of contractors we knew who had good experience with LVL. On day one we fronted up at our presentation on competition day with a third scale model made out of LVL of one of our realisable bolted joints. And so pretty much from day one we've always thought about this as an LVL structure. The notion of how we make buildings in New Zealand, I think, is going to change in the wake of the Christchurch earthquake. It's sort of the protagonist at the moment. I think whether or not carbon develops a value, we're going to have to start thinking about our resource more carefully. And so what we're finding is that locally we've got tenants rather than developers asking for seismically protected space and for buildings that are made using something other than concrete. I think there's a wee bit of a concrete phobia come out of Christchurch, and so we've got two jobs on the books where developers are responding to someone else's needs and saying we want this to be earthquake proof and we want to increase the amount of timber we're using.